Bismillah, alhamdulillah, wa salatu wassalam ala rasulillah. Today, inshallah, we will continue section 2.8 and we will finish it, inshallah. Today, we will also practice by solving some recitation exercises and all the exams, if we can, of course, and we have time for that. Let's remember what is this section is about. It is about one-to-one function. Ask yourself, do you know now what is one-to-one function? How to identify between the function that is one-to-one and that is not. Also, what is the inverse? What is the definition of the inverse of a function? What we mean by it, and how to find it, and how to sketch the graph. I think we have achieved most of these objectives in the previous class. What is remaining today is just the graph. How to relate the graph of the inverse to the graph of the function. How to obtain the graph of the inverse from the graph of the function. But before that, let's go quickly over what we did yesterday. This is the definition of the one-to-one function. The horizontal line test, which is the best test to use to decide about if it is one-to-one or not. I'd like to emphasize on this, Shabab. If you want to give a definition for the one-to-one function, just look at this one here. I'm talking about this expression because it is related to the definition of the function. So if you have a function y equals to f of x, this function is called one-to-one if what? For each x value, there is a y corresponding y value, and for each y value, it corresponds to x value. One, exactly one. The cubing function, it is an example about one-to-one function. X squared over its entire domain, it is an example about the function that is not one-to-one. But if we restrict the domains such that we will take only the increasing part or the decreasing part, it will be one-to-one. We generalize that every continuous monotonic, which means increasing always or decreasing always, it is always one-to-one. Every non-horizontal linear is one-to-one. So if the graph is horizontal, is not one-to-one. So the constant function are not one-to-one. They are in fact all to one. We solved this recitation exercise in the previous class. We also defined the inverse. Here we are. The most important part, if you have a one-to-one function, then its inverse is a function, and it is given by this definition. When we say f inverse of y equals x, this is equivalent to saying that f of x is y. What is interesting is this fact that the domain of the inverse is the range of the function, and vice versa. The range of the inverse is the domain of the function. We solved also this old exam question. And then we moved to the cancellation property or the inverse function property. This is so important. It is about the composition of the function with its inverse is from the left or from the right is equals to x. So it looks like they cancel each other. They are indeed, they are canceling the effect of each other. So you will have the identity function at the end. This property can be used to check if you have two functions, how to know that they are inverses of each other. Use this property. If they cancel each other, if g cancels f and you get x at the end, then they are inverses of each other. Just be careful here, guys, that this x here is not the same as this x. This x, it is in the domain of f. It is inside f. So it is in the domain of f, which is the range of the inverse. Here, it is where? It is inside the inverse. So it is in the domain of the inverse, which is the range of the function. Okay? So we solved also this exercise in the previous class. We learned how to find the inverse, and we solved several examples for that. For the rational function, linear over linear. I think we have stopped at this slide in the previous class. We know that the restricted x squared is one-to-one function. And to find the inverse, you will follow the same process that we have. We will replace f of x by y. It is, of course, better to have y from the beginning, to have the domain of the inverse from the beginning. How to know that? From the range of the original function. Here, you can obtain it from the graph or from here. Since y is x squared is always greater than or equal 0. So y will be greater than or equal 0. Now, you will take a square root of both sides here. You will take square root of both sides. Then here you will have absolute value of x equals to the square root of y. But x is non-negative. So because x is non-negative, we will replace the absolute value by what? By x, not the absolute value of x is equals to x when x is greater than or equal 0. You know that. Now what you will do, you will interchange x and y, and don't forget to interchange here also. So here it becomes, this x becomes y and this y becomes x. So this is the inverse. The inverse of x squared when x greater than or equal 0, it is the square root of x when x greater than or equal 0. And if you sketch the graph of the inverse, the square root of x, you know how this graph looks like. You can notice if you draw them together over one graph, you can see that they can be obtained from each other. How they can be obtained from each other? In fact, the graph of the square root of x, it is just the reflection of the graph of x squared when x greater than or equal 0. Just if you imagine that there is a mirror here, and this will be just the image of that one here. So it is about reflection about the line y equals x. Why specifically this line? Because of the interchanging. This is the inverse. What is the inverse process? The domain is the range is the domain, the x here, it is y there, and so on. We will generalize this idea in the next slide. But before that, let's finish talking about this function. We are done with this part. If you have x squared and x greater than or equal 0, this is one-to-one function, and its inverse is this. This is what we have done here. Also, I want you to do this by yourself, of course. You can do it easily. If the condition is x less than 0, just if you take the negative branch, the inverse will be what? Negative the square root of x, and x greater than or equal 0. So the inverse, the graph of the inverse will be what? The same, but reflected in the y-axis. You know how to sketch the graph of y equals negative square root of x. Let me do it for you. This is the graph of the function. So this is y equals to x squared and x less than or equal 0. So where it is? Here it is. This is the graph of this function. Now the graph of the inverse is y equals negative square root of x. So what? It is the same as the square root of x, but reflected in the
y equals minus x.
Is it reflected in the x-axis or the y-axis? You need to revise, ya shabab, section 2.6. Please. No.
The minus is outside.
No, you need to revise section 2.6 about the graphing techniques. When you have a function, if you replace x by negative x, this is reflection in the what? In the y-axis. If you replace the whole function by the negative of that function, so this is the same as this. Look at the red one. It is the same, but reflected in the x-axis. So this is the graph of negative square root of x. Please. Okay. Let's now go to the last part of this section. How to graph the inverse of the function, how it looks like, and how it is related to the graph of the original function. You know from the definition of the inverse, if you have f at a equals to b, this is equivalent to f inverse at b equals a. This means indeed if the point a and b is on the graph of the function, this point, what it will be in the graph of the inverse? It will be b and a. X will be y and y will be x. So in fact, if this is the graph of the function, and this is the point A, and this is B, here it will be this is B, and this is A for this point. So in fact, this is just about reflection. It is about replacing x by y and y by x. So what is A here? What is x becomes y? What is y will becomes y x. So if just reflect, if you have the graph of f or the graph of the inverse and you want the another graph, just reflect it in the line y equals x. This is a very interesting fact, very useful for you if you can use it. The graph of the inverse is obtained by reflecting the graph of the function in the line y equals x, and the graph of the function obtained from the graph of the inverse by the same way. Let's apply this with this example. Part A, sketch the graph of this function. So easy. It is square root of x shifted 2 units to the right. You are right. Now, part B, use this graph to sketch the graph of the inverse without finding the inverse. How can you obtain the graph of the inverse without knowing what is the inverse?
Substitute any 2 points?
No.
I have a point and 2 and 0. I will make it 0 and 2.
So this point here, 2 and 0. In the graph of the inverse, it will be what? 0 and 2. Here it is. This is the first point in the graph of the inverse. What else?
And we have y equals x. And
You can do that for other points as well. But it is, in fact, easier than that. You are engineers. You have to know how to do that easily. As I said, what we said here, Shabab, the graph of the inverse is obtained by reflecting the graph of f in the line y equals. So what we will do, we will just draw the line y equals x, and then we will try to sketch the graph of the image of this one here, the reflection of this graph. So if you reflect that graph, if you think about this line like a mirror, this is how it looks like in the mirror. This is the graph of the inverse, even we don't know what is the inverse. Of course, this is not always easy or exact. Sometimes you have to be sure about it. Taking this point will help you a lot. When you thought about 2 and 0, it will become 0 and 2. This is very important. 1 point will give you. You can add more points to make sure about it. Excellent. So you know how to obtain the graph of the inverse from the graph of the function. Let's go to the third part. What is it? Find the equation for the inverse. Now, of course, if you have the inverse, you can sketch the graph. But now we can find the inverse by the methods of yesterday. Both y equals to f of x. Solve for x, interchange x and y, and that's it. This is what we will do. So we have what? We have y equals square root of x minus 2. This is the function. What we will do? Y is greater than or equal 0. From where we obtain this?
From the domain of the question.
So our function, let me repeat. This is our function. X is clearly x greater than or equal 2. This is the domain. What about y? Y is the range. Is it greater than or equal? It is square root. Square root is always greater than or equal 0. And you can look at it from the graph. Look at the blue graph. What is its range? So here we are. Then what we will do, we will solve it for x. We will square both sides. So when we square both sides, no absolute value here, no positive or negative. Why? Yes. Please pay attention, guys, because this is a common also mistake for some students did. The square root of x squared is what? Absolute value of x. But the square root of x all squared is equals to what? X. Why?
Always
this quantity will not be exist if x is negative. So x here is positive because it is the square root is defined here. But here it could be positive, it could be negative. Okay, so here no absolute value, no positive or negative. And now we need to solve it for x. You will add 2 for both sides. Now what we will do? Interchange. So this x will be y and this y will be x. And don't forget to interchange here also. Here we are. And this is what? This is the inverse. What do you think? is the graph that we did before, is right? Is correct? Yes, this is the graph of x squared plus 2. It is just x squared shifted up 2 units, but don't forget that x is greater than or equal. We are taking just the positive branch. Okay. Excellent, the increasing side. That's it. We are done with the section 2.8. الزبدة هنا موجودة. This is the summary of this section. The one-to-one, the horizontal line test, how to obtain the graph, the definition of the inverse, the most important property, the cancellation property, how to find the inverse, domain of the inverse is the range. This is for rational functions, how to find that. But there are many tricks that I'd like to learn with you. These are, ya shabab, some solved exercises. I advise you to resolve them again. Try to resolve them again. Don't look at the solution, try to solve it by your own. And then check. I will leave it for you to practice. This is about finding the inverse. Again, I think you are now aware about how to find the inverse. Don't forget to consider the domain when you always express the because if you say this, look, if your answer is like this without this, it is wrong. It cannot be. This cannot be inverse for a one-to-one function. The function and the inverse both should be one-to-one. They are inverses of each other. So do not forget the conditions, the restrictions. Find the inverse of this function. You know how to find the inverse. You will put y equals to, okay? So you will put y equals to square root of 4 minus x squared. And now it is better to have the range from the beginning to know the restriction at the end. So how can you find the range from here?
By replacing the 0 and 2.
Substitute
From 0
values.
to values.
It is also between 0 and 2. Okay. In fact, this is about how to find the range. You can revise math 001 again, but I'll show you how. Why it will be like this. Do you remember that this is an equation of a circle centered at the origin with radius equals to 4, radius equals to 2? Okay. Now this function here represents the upper part, right? Not only the upper part, the upper semicircle, the upper half of this circle. Not only that, because of this restriction, of course, this is not one-to-one. Do you agree?
Yeah.
It is not one-to-one. It is a function. Before it is not a function, the equation of the circle. Now it is a function, but it is not one-to-one.
Yeah.
Now with this restriction, it becomes one-to-one.
Yeah.
X between 0 and 2, so it is just in the first quadrant. Now this function is one-to-one, and this function is the graph of our function. Now, what is the domain? From 0 to 2. What is the range? From 0 to 2. So now you can know what is the domain, what is the range. You can process as we usually do. We will square both sides, then you will take the square root of both sides. Here we will take, of course, square root. Here it will be the absolute value, but here x is what? Positive. No need for the absolute value. So you will take the positive. And you can have the inverse. This is the inverse. What do you notice?
We just replace the y with x.
Hasn't changed.
Again?
Hasn't changed.
So
So
the inverse of this function is itself.
Yeah.
The same function with the same domain. And it was expected from the beginning. No need to do all of this. You remember that the graph of the inverse is the reflection of the graph of the function about the line y equals x. This is the line y equals x. Reflect this. This will be here and this will be here, and we will get the same graph.
Yeah.
So what we conclude from this, you can generalize this not only for 4 here, whatever here. You have a squared or r squared, whatever. For any number here, you can apply the same idea. So I will do that for you in the next slide. Yes.
Can we find the range without cuts the graph?
You can by building the function, yes, but it is much easier to know that. This will save your time. Look here, how many functions we will play here, like with 4 functions. Let's say 8, because we can talk about the inverses also. So here, this is the upper semicircle, this is the lower semicircle. This is the positive part, this is the negative part. if you solve it for y. For this one, its inverse is the itself. What about if you are in the third quadrant? Now the negative, it is the negative part. The domain is between -2 and 0. Now again, if you reflect this graph about the line y equals x, it will be the same. So the inverse also is the same function with the same domain with the same range. Now, if you are in the second quadrant, so here we have the positive part, the upper, but x between negative what? -2 and 0. The range is from 0 to 2. The inverse will be where? This is the line, Shabab, the line y equals x. Where will be the inverse of this function? It will be here. Here it is. This is the inverse of this function. What is it? X between 0 and 2. The range is from -2 to 0. Now, if you are in the fourth, the same, the inverse will be here. This one. Here we are. So the summary of all of these is here. And you can now, if you have a question of this type, there are many in the old exams and in the recitation. The idea now is with you can do it as quick as like this, because you know that they are part of a circle centered at the origin. This is an exercise about how to find the inverse of a quadratic function. How to do that? You need to solve it for x. You can solve it for x. Do you remember the first class when I asked you to solve for x? You can do that by using the quadratic formula. But it is better to use the completing the square, because you will obtain so many informations. When you complete the square, you can find the vertex, you can sketch the graph, you can find the range. So this is what indeed you need to do. It is better also to know the domain of the inverse. And to know the domain of the inverse, you need the range of the function. So to know the range of the function, you need to complete the square. So to do that, you will complete the square. From here, from this step, you know what is the range. What is the range?
-5 to
Y is what? Y is less than, greater than? Greater than -5. So this is the domain of the inverse. And you can't continue. You have absolute value. Don't forget that you have positive or negative, but you have to consider the condition that you have. We will solve, by the way, one question, I think, in the recitation. I will leave this for you also, this for you to practice. Please, ya Shabab, do not read solutions. Solve, and then after several attempts, try to check the solution. Don't go to the solution from the smallest or the least difficulty. In the slides of this semester, ya Shabab, I removed the exercises that we had from the textbook. I replaced them with this. Suggested review exercises, and this is from the syllabus. These exercises are suggested in the syllabus of the course, if you can find it. Yes.
Okay, we have the step where the absolute value of x minus 3 equals the
Yes.
square root. Why did you make the square root of the?
It is okay. You can put it here. It is in fact here. X minus 3. The negative is here. But usually you remember when we say the absolute value of u equals to c, this means that u is positive or negative c, right? So here, in fact, x minus 3 is positive or negative, the square root of y plus 5. Why we take the negative? Because what is inside, you need to ask yourself, what is inside the absolute value? Is it positive or negative?
Negative. I will be
You need to check this. It is less than 3, so this will be less than 0, so you will take the negative sign. Okay. We will solve, I think, one question about this. We solved this in the previous classes. The second recitation exercise is about 3 parts. You need to find the inverse and the domain and the range of the inverse. The first one is done. We did. Just check exercise number 7. We will solve this. Also, this one, we solved a similar one in the previous class. So you can check example number 9. So let's solve this one, please. In your notes, try to solve this exercise. For the following function, find the inverse and state its domain and range. What is it now? This is the last time. I don't want your Shabab to see, please. Anyone without. You can take a favor, please.
Okay.
What's our nothing also? Thank you. It is so important to practice inside the class during the class. Okay, who has an answer? Let's check.
This is the answer.
Let me just put this one here. Okay. No. Check. And it is not practical to say x equals to r. X equals to r?
Yeah.
No, the domain equals to r.
Domain
Equals to r, not x. Oh, it is not, by the way, it's not about that. It's not correct. Not correct. The domain is on the right number. Be careful. Function inverse. Right. Yes, you're right. Excellent. And of course, yes, XX. No. Yes, it should be Y. Okay, this is enough. We will check with you for with others. We will check the other questions. So you can check now your answer, Shabab. The answer is this. The inverse is x minus 2 all squared minus 3. It is a parabola. The inverse is a graph of a parabola apart from a parabola. X is greater than or equals 2. So this is the domain of the inverse, and this is the range. How to obtain that? For those who didn't, let's solve this together, and you have to solve the next one. So again, to find the inverse, what you will do?
Yes.
Replace f of x by y. Now, remember that x is greater than or equals -3. It is given for you. Of course, it is the domain. It is the natural domain of this function. Now, if you can find y from here, it will be much better.
Yes.
And you can. You know, Shabab, that the square root of 3 plus x, it is greater than or equal what? So when you add 2 for both sides, and this, of course, your y. So y is greater than or equals 2. You can also, if you didn't realize it from here, you can realize it from the graph. This is the graph, in fact, of the square root of x shifted 3 units to the left, then shifted up 2 units. So it is starting from 2. Y starting from 2. Okay. Now it is about solving this equation for what? For x. You can interchange. Some of you, they prefer to interchange here x and y. It's okay. So now we will solve for x. So we will move y to here. Why it is important to find y from here? Because you will lose your y if you didn't find it from the first step. So it will be square root of 3 plus x. Then you will square both sides. Then you will add -3 for both sides. So x will be equals to what? -3 plus y minus 2, or let's put it at the beginning in the same order. Y minus 2 all squared subtract 3. Now, here you can interchange now. So remember what is the conditions? What are the conditions that you have? Here we are. Before changing now, you will change also here, and don't forget to change also the conditions here. Now you are in the last step, and you can expand this, by the way, if you want. It's okay. Now just you need to write your condition. Without this condition, this is not a one-to-one function. It will not be one-to-one. So now again, as I said, I saw some of you, they write it like this, negative 2x plus 4 minus 3, it will be plus 1. It's okay also. This is 4. Yes, you are right. So it is x squared minus 4x plus 4 minus 3, it will be plus 1. It's also an answer.
Doctor,
Yes.
why did you write it's greater than or equal to 2, but you didn't write
It's okay if
condition for y?
why not? But usually when we want to express that it is one-to-one, this is enough. Of course, it is not a problem if you write that. And it is clear indeed, clear from here, because this is always greater than 1, this is negative. But it will not be easy clear for you that x here should be greater than or equal to 0. Because I saw, for example, you said that the domain of the inverse is all the real numbers. Why? Because you looked at this. No denominator will be 0, no roots will be negative, so everything is nice, so it is all the real numbers. But unfortunately, it cannot be inverse for any function because it is not one-to-one. So this condition is in fact for the function to be one-to-one. And it comes by default from the range of the original function.
So the inverse is only for one-to-one function.
Of course, look at the definition of the inverse. If the function is one-to-one, we can talk about the inverse function. Otherwise, the inverse is not a function. Okay. Now, again, I want you to solve this, please. If this is a quadratic function again, the x is less than 2, look at the importance of this condition here to make it one-to-one. Without this condition, it's not one-to-one. Then find the inverse. What is the inverse? Try this time to solve it. You didn't solve the previous one, so please try to solve this one. Think, practice. You didn't turn on your brain in the back class. When you do that? Don't write the question. Do not write the question again. The question is there. Just write the function start work. Good. No. Check again. Go back. Go back and think it different. Correct. You forget something here. What is it? From where it comes? It's not the way that you want to do that. You added here, but you didn't add here. Yes. Do it at the same, in the same side. Remember, as we said yesterday, it's good to do some mistakes at the beginning to learn from your mistakes. You are not following the process. What we said, what is the first step to do when you want to find the inverse? Replace f of x by? You didn't do that. Just remove f of x and replace it by y, then try to solve. So far is good. Okay? So the inverse, you have options, by the way, A, B, C, D. Which one is the right choice? So according to your solution, your answer is? Your answer is C. Okay, we have C. What about your answer? It is D. According to your solution, it is D. C. We have C and D. We have two C's and one D. What is this? C. C, are you sure? Well, C, I don't think so. We will see. We will see if it is C. Yes? Who can give us a hint? What is the main trick here in this question?
Multiply by minus.
Yes.
No,
Take
it is not about multiplying. You can say it in another way. Yes.
take the common factor from the start by minus. Then
Completing
The square.
the square. And when we complete the square, there is something important that we should be aware about. So first of all, let's check the answer. The answer is C, and you are right. So it is not D. The answer is C. Why it is C? And how to find the inverse. First of all, you should follow, Shabab, the process, please. I saw some students, they do anything. They don't know what to do. So first of all, you replace y by what? This function, replace it by y. So it will be negative x squared plus, let me do it here, negative x squared plus 4x, and x is less than or equal to. Unfortunately, you cannot decide about y because it is important to know what is y. But when the function is like this, you cannot. What you need to do is it is quadratic function. You need to complete the square. Multiplying both sides by negative, it is not a good idea because you will change the function. If you multiply both sides by negative, what you will have? You will have negative of the function equals to x squared minus 4x. We are looking for the inverse of the function, not the inverse of the negative of the function. So do not do that. Do not do that. This is maybe the reason you did a mistake. So look here and learn from what we are going to do. If you want to complete the square, the coefficient of x squared must be positive 1. Positive 1. So what we will do, we will take negative as a common factor, open brackets. I saw many of you, they did that. So this is step number 1. You still unable to figure out what is y. So what you will do, you will go inside the brackets and you will complete the square. To complete the square, you will ask yourself, what is the coefficient of x? Negative 4. The half of it, negative 2. The square of it is 4. So you will add 4 and subtract 4. You just add 0. And we still unable to figure out what is y, but it's okay. Soon we will be able. Now, the first 3 terms are what? Perfect squares, right? Check. Now, this negative 4, it will be multiplied by this negative. It will be plus 4. And now we can decide now what is y. How to know what is y? What is this, ya shabab? This is a parabola. It is just x squared shifted 2 units to the right, reflected in the x-axis, shifted up 4 units. In other words, this is of course x. Let me do it here for you. X minus 2 all squared greater than or equal 0. When you multiply it by negative, it will be less than or equal 0. When you add 4 for both sides, here we are. What is this? This is y. So y is greater than or less than or equals what? 4. So this is not an option. This is not an option. But forget about the choices. Now, why we did that? Because we need to know the domain. Now, what we need to do more? We will solve this equation for what? For x. So you will add now. Let me move this. The negative part. I will move it to here. So I will have what? 4 minus y. Is that right? No. I just moved this one to this term to here, and then y to there. Now I will take the square root of both sides. I think we can do that. Take square root of both sides. Here we will have what? The absolute value of x minus 2 equals to the square root of 4 minus y, which leads to x minus 2 equals to positive or negative square root of 4 minus y. But we can decide here. This is not an option, Shabab, by the way. If you look at this, this is not an option because this is not a function. For each x, you will have 2y. Now here, which one we will choose? What do you think? X here, it is less than or equals 2, y is less than or equals 4. So because x is less than 2, so this will be positive or negative? It will be negative. So we will take the negative part. X is less than 2. So it will be negative, and then add x for both sides. It will be 2 minus 4 minus y. At this step, we will interchange. So to interchange, what you will do, let me do it for you here. We don't have enough space. So the inverse of the function, which is x here, will be y. 2 minus square root of 4 minus x, and x will interchange. So this x will be y, and y will be, so x will be less than or equals 4. This is the inverse of the function, without, of course, any much needed steps, because here he restricted, of course, the domain. By the way, this is the graph of this function is 1-to-1, even without this restriction. Okay, but the restriction is coming from the function itself, from the domain, the range of the function itself. Okay, any question? Before going to the last question, we have time for the last recitation exercise. I think this is the last one, if I'm not wrong. Let f of x be what? Rational function, linear over linear. And if inverse exists, so it has inverse. So this means that it is 1-to-1. If the value of the inverse at -2, it is 1, then what is the value of k? Think about it. Try to solve it. He wants the value of this k here. You have the function. It is given for you that it has inverse. And the value of the function at the inverse, the value of the inverse at -2 is 1. You got an answer? MashaAllah, tabarakallah. What is it?
1. Yeah.
How you did that? That's quick, mashallah. What you did, yeah, Abdulaziz?
By the dimension of the inverse, say f of 1 equals -2. So f of x, replace it with -2, and replace x by 1, and get.
You're right. You're right. But I'm wondering, mashallah, you did it in like in less than like 10 seconds. Continue, guys. It's okay. Continue. Try to find out what your colleagues have done already. So you can find the inverse here, by the way, but you don't need. You can find the inverse one way to find the inverse, and then use this one. But it is a very long way and unnecessary step. Just use the idea that the inverse, this is equivalent to what? F at 1 equals to negative. From where we bring this? From the definition, f inverse of y equals to x, f and only f, y equals f of x. So if you have this, you have this. If you have this, you have this. They are equivalent. So this is, in fact, you don't need the inverse. Khalas, by the inverse, you have the function. Now you will go here, replace x by what? By 1. So you will get what? 3 minus k over 1 minus 2 equals to -2. You have equation with one unknown, which is k. So this will be 3 minus k over -1 equals to -2, which will be what? 3 minus k equals to 2. Multiply both sides by -2, by -1. Then move k to the another side. It will be 3 minus 2 equals to k. K equals to 1, and you are right. K is 1. So easy. So what is the concept that we used here? This is the main concept. This is the main step. Otherwise, it is 0, 0, 1. Just solving equation. The inverse of this function is given by the way, I solved some few all the exam questions for you at the beginning, like 3 or 4. Let's say 3, 4, I think. And of course, I will let the others for you to be solved Try to practice by solving the other old exams. Try to avoid the ready solutions. Try to learn from, live the exam environment. Imagine that you are in the exam and you have this question, what you will do. Okay? Do not look at the solution. Check the solution after you try, and several tries, not only one attempt. Try to try and try and try. Let's try in the remaining 2 or 3 minutes to solve this. Which one of the following function is not a one-to-one function? Which one is not a one-to-one? It means that we have 4 one-to-one functions and only one that is not. How to know? What is the strategy of solution? Yes.
By graphing, and you show the decreasing bar or the increasing bar. And he took them both.
I think if there is a problem, it will be A or D, right? Let's see. For B, for each X, there will be only one Y. And also, I mean, for each Y, there will be one X, because here we need to check. It is a function, but just is it one-to-one or not? So here, for the first one, if you think about it, it is just, what is f of x here? It is x minus 1 all squared, and x is less than or equals 1. What is this? This is a parabola. This is just x squared shifted 1 unit to the right. So it is at 1 here. And x is less than 1. Right? It is just the parabola, but we didn't take the increasing part. So it is one-to-one. What about this? It is square root, and you know square root is increasing always. This function, it will be decreases when you reflect it. So it will be like this at the beginning, then reflected, it will be like this, shifted up. So it will be one-to-one. For this one, there should be a condition here, by the way. Because, yeah, Shabab, I know that this is 1 over x, right? This is the graph of the function 1 over x. This is the same as this function, but shifted what?
1 to the right.
1 to the right. So the horizontal asymptote, you can, by the way, if you want, you can write it as x minus 1. It will be 1 plus 3x minus 3, which will be 3x minus 2 over x minus 1. It is one-to-one, right? Because if you sketch any horizontal line, it will intersect it only once, okay? So it is one-to-one, and in fact, the domain is over there. So the problem is at D. In fact, you are right. The answer is D. This is, in fact, the function here is what? The absolute value of x minus 2, and x is greater than or equals what? 0. He didn't say 2. If he said 2, it will be. So now this function, in fact, the vertex is here, and he said x greater than or equals 0. So it is like this. At 0, it is 2. So this is the graph of this function. So because if you sketch a line here, a horizontal line, it will intersect it more than once. Okay, so the horizontal line test is the best way to know if it is one-to-one or not. Thank you, and see you